Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called top k frequent elements. So in this problem we have been given an array of integers and we need to return the k most frequent elements. So when I say most frequent elements means like that's the frequency is highest, right? So let's try to understand. Let's say I am having this integer array for example, then 1 is occurring 2 times and 2 is occurring 3 times, right? And this 3 is occurring only one time, right? And if they are asking like k equals to 2, then I have to return 2 and 1. So this would be my output, right? So 2 comma 1, this will be my output. Let's take a couple more examples. And yeah, another example is like if it is 1 in example 2, right? Then in that case output would be 1 itself because there is only one element. So this is the most frequent elements, that frequency is 1, right? So I hope problem is clear. So now if the problem statement is clear, we can move towards the solution part. And let's build some example and then let's try to understand how we would solve this problem. Let's say we are having this array, right? So let's say if k equals to 2, then we need to return first 2 because it's occurring 3 times, so the output would be 2. And because we need to return uh, most frequent 2 elements, right? So most frequent one is 2 because it's occurring 3 times, another is 1 and 3, right? So we can return either 2 comma 1 or we can return 2 comma 3 as well. Both are the valid output, right, in this particular case, because both frequencies 2, one frequency is also 2 and 3 frequency is also 2. So one pattern is clear after observing this problem is, first of all we need to get the frequency of integer, like how many times one particular number is coming. Once we know the frequency, then the topmost frequency we need to get this frequency, it's 3, so we need to get the top frequency on the top, so then we will get 2, right? And now we need to get the lower frequency than highest frequency. So lower frequency, I mean the second last frequency is 2, so the corresponding number might be 1 or it might be 3 as well, right? So 2 comma 3 or 2 comma 1. So to solve this kind of problem, there is a built-in API that's called priority queue in Java. There must be other way in other language as well, I'm sure, but in Java we are having priority queue, and with the help of priority queue we can sort the frequency and then accordingly we can put the output. So there are 3 steps to solve this problem. Step number 1, then we need to record the frequency of each and every integer. Once we know the frequency, then we can take the priority queue, that's the built-in API in Java. With the help of priority queue, we can use that priority queue and then we can just sort based on the frequency, right? So we can just take in this case max heap. So priority key is nothing but heap implementation, right? So we will take the heap implementation in such a way that the maximum frequency will be on the top and it will be in the descending order, right? So once we build that priority queue, once we declare that priority queue, then the third step would be just to fill our output list from the priority queue. So these simple 3 steps we can do that, and the time complexity in this case will be n log k. Why n log k? Because n times we need to iterate, so that's why it's n log k, is because we need to pull that priority queue k number of the times, because of we need only uh, top k elements from the priority queue, because the highest frequency would be like on the top of the priority queue, right? So that's why it will be n log k in this case. But if we refer the problem itself, in the statement they are saying that your algorithm's time complexity must be better than order of n log n. All right, so let's first of all try to solve with the priority queue, and then we will optimize that further, and we will say that how we can improve the time complexity from log k to probably linear complexity. So let's go ahead and create a couple of placeholders first of all. So frequency, I'm just creating one frequency map here to record the frequency of every integer here. So let's go ahead and do that. Alright, so integer I equals to 0, I is less than nums dot length I plus plus, and then frequency map dot put nums I comma frequency map dot get or default nums I comma 0 plus 1. So what it's doing, it's getting default if there is no frequency, otherwise it's getting the frequency, current frequency, and then increasing by 1, right? So we are just incrementing the frequency of every integer. So this is step 1 that I was explaining, right? So step 1, oops, I wanted to make S as capital letter. So step 1 is record frequencies of each integer, right, in array, right? So this is step 1. Step 2 is take priority queue. And step 3 would be fill our output list, right? Fill our output list and return it. That's it. So this is the 3-step process. So now let's take first of all output list as well. So list of integer result equals to new array list. Alright, so if let's say for example if my given array itself is null, then I don't need to do all this thing, right? Step 1, step 2, it's not needed. I will return from here itself. So if my array, given integer array, is empty or the length itself is 0, then go ahead and return this dummy list that I am building. Alright, now let's go ahead and create this priority queue. And because here I am taking the map to record the frequency, right? So if I clear this board here, so map looks like this: key and value pair, right? This is key, this is value. And the way we access this key value, there is another interface that's called entry, and entry is nothing but it's just to access this key and value. So I am just going to take map.entry here, just a heads up, and it's just to access this every key and every value with the help of entry. So entry is nothing special but just to access. So entry, you can say that each entry in the map itself. So let's go ahead and take that as well. Map.entry integer integer pq equals new priority queue. I'm going to use here the traditional way. I mean, the traditional way is like Java 8 is super compact, but this is what I feel. It's pretty lengthy actually, new comparator and then override the compare rather than just have the compact version, but somehow I prefer this one even if it's lengthy. So map.entry integer, right? So this is the entry. Now we need to override this compare method, public int compare, and here also as an argument we need to take map.entry integer comma integer. This is first argument. Let's take second argument here itself, entry, integer comma integer b. Alright, so this a key is particular number and the value is the frequency itself, right? And we need to get in the descending order, so we will do b dot get dot value minus a dot get value, right? So this entry is, as I told, this is just a way to access this key on end value. So I say the map dot get key will give me the key and the frequency, corresponding frequency 2 or 3, it can be anything, right? So alright, step 2 is complete. Let's quickly jump to the step 3 where we need to fill the output list. So to fill the output list, what we are going to do, we will just check like our PQ. So take the priority queue, and step 2 includes and add the map to priority queue. Okay, PQ means priority queue here. So just go ahead and add all. Why add all? Because it's a collection. I want to add all the collection entry set. So entry set is again nothing but it's just a entry, but it's just kind of the map only, right? Just to access the map. So if my priority key is not empty, right? Oops. If my priority key is not empty, and because I need to get till k size, so what I would do, res dot size is less than k, right? So this I will just keep filling this output list till its size is less than k, right? Once it reached k, I'm done, right? So let's go ahead and do that. So res dot add pq dot poll. So pq dot poll will give me this entry, map dot entry it will give, and entry, as I already told you, it's just a way to access the key or value, right? So I will just need to get the get key, that's it. I don't need the value, right? Because value I already added here the frequency. So these are the frequency in the map. Values are the frequencies in the map, right? And on the basis of the values, I'm just adding them in the descending order in the priority queue. And you can think of this priority queue is the built-in thing. You don't need to think about logic or anything. This is like pretty much placeholder that you need to take from. This is just an API, so we don't need to use any other logic to build this priority queue, right? So just if you want to deep dive, just go ahead to the documentation how this heap thing work, heap sort and all, right? But this is the way that language already provides us, and we are just adding, and this is pretty important for couple of problems actually. This placeholder, we are just adding our map into this priority queue and just returning this output result. All right, and we are done. Let's quickly check for time complexity n log k, and space complexity is order of n. Why n log k? Because we will be polling from the priority queue exactly k times, right? So in the worst case it will be n log k, right? I mean because we are polling the k times, so that's why it will go log k, n log k, and n is because we have to iterate anyways, we have to go through each and every element, so that's why it's n. But because of the priority queue, so whenever we do the heap sort, it's already n log n, right? Heap sort, merge sort, they are n log n complexity, and here because we have the constant of the k, that's why it's n log k. So let's quickly check for the compilation error. So I forgot semicolon. Let's see other compilation error. Alright, so let's go ahead and add the closing bracket. Cannot find symbol. Okay, there are too many typos. Let's correct those. Cannot find symbol map because it's frequency map, and somewhere I took it as a map, so that's the again another naming convention typo. Okay, so finally it worked, right? So I'm taking it here as a key, right? Not value. Value is the frequency, key is the actual number, and we need to result as a actual number itself. Let's go ahead and quickly submit this and let's see whether it's getting submitted. So looks like it's working fine. Now let's come to the optimization part. Now as we learned like how to solve this problem with the help of priority queue. Now let's go to the whiteboard here and let's clear this guy and let's take our any other integer array. So here what I'm doing, I'm just using the heap sort to do this sorting thing, right? And if I don't use this heap sort, then what I can do, if I don't use this heap and internally heap is doing heap sorting itself, right? If I don't use that, then what I can do, I can just I'm already recording the frequency right in the map itself. So one key and value. So let's say for 1 frequency is 1, for 2 frequency is 2, for 3 frequency is 1, and for 4 frequency is 2. So this is the map and this is what I am just recording, this key, and this is the value. Now what I can do, I can just maintain another list, right? I can just maintain another list rather than using the heap. I can just maintain another list, and where I can just bucket basically based on the frequency. So what I mean, like for example, this frequency is 1. What I can do, let's say the total element is 1 2 3 4, right? So the total number, yeah, total unique elements is 4, but this nums basically this length is 1 2 3 4 5 6, total is 6, right? So what I can do, I can just take another list, additional list, 0 1 2 3 4 5 6, right? So this is having um, actually the seven placeholders. 0 to 6 means 7 placeholders. This is index wise. Why I'm taking 0 to 6? Because maximum frequency can go till 6, right? Because they are having total element is 1 2 3 4 5 6, total 6 element, right? So maximum frequency can go till 6. In the worst case, 1 can be repeated 6 times or 2 can be repeated 6 times, right? So that's why I took this bucket. This list is 6 as the length of 6. Why I am taking 6? Because I want to bucket. When I say bucket, it means, let's say this 1, right? So what I would do, I would just add this 1 here, right? 2, and 2 frequency is 2 itself. So what I would do, I will just add this 2 here, because 2 bucket means this is the size, right? This is the size. 0 1 2 3 5 4 5 6, this index belongs to the size, right? So 3 is basically 1 frequency. So what I will do, 1 is already there, so I will just add 3. I will just append 3 here along with 1, because this is the size of 1. 4, so 4 frequency is 2, right? And in fact 3 frequency is also 1, so I already added 4 frequency is 2. I will add along with 2 4. So now what I know here, that there are some elements, there are a couple of elements that's frequency 2, and I know they are 2 and 4, right? So if I know they are already 2 and 4, then what I can do, I can just iterate this particular list from the last. So from the last, if I go 6 is nothing, null, 5 is null, 4 is null, 3 is null, but 2 is not null, means it's having some element, right? Then what I can do, I can just take these guys 2 comma 4 and I can fill my output list. For example, I need to get only k equals to 2, right? So this is key, this is not k. Don't get messed up with this k to this k. So if k is 2 and I already know this is having only 2 elements, right? So this will be my list, I mean this will be my output list filling with 2 comma 4. So this is the another way to solve this problem, and the benefit of this solution is I'm not going to manually doing the sorting, but I am just maintaining this list as a bucketed list. That this bucketed list I am telling my index as a size. Okay, so my index 2 means frequency 2 will come here, frequency 3 will come at the index 3, frequency 6 will come at the index 6, right? So, and I will attach that particular element with that frequency to that particular index. and that's it. Once I dump that into my bucket list, I can just iterate my bucket list from the last, and I can fill my output list. That's it. So this is the another simple solution. Let's go ahead and try to modify this solution. So priority queue we don't need here. In this case, step 2, what we will do, we will take buckets list, right, such that each index will denote the frequency, right. Let me maximize this. All right, so each index will denote the frequency of particular element, right. Step 3 is the similarly fill the output list and return it. So let's go ahead and just build our bucket list first of all. So let's say list integer, and this is the array. So what I'm doing here, basically I'm just building this output list, and this output list may contain the list itself. So as you see here, I'm just appending 2, 4, 1, 3. So it's basically the each index may contain the list itself. So that's why I'm taking the list array. All right, so let's say this is buckets new array list, and as it is array, I need to take like nums dot length +1. Why I'm taking +1? Because let's say these are the six element, then I need the 7 size, right? Because this is the index wise, so it will go from 0 till 6. It means I need the 7 space, means one more space. And the reason of that, because everything is index wise, and the maximum frequency can go till the maximum length, right? So when I say maximum length is the actual length. So actual length here in this case is 1 2 3 4 5 6. So 6 is the length. Maximum frequency can go till 6. That's why I need to get another additional space basically to get that length as well. And because it is index wise, that's why I'm taking nums dot length +1, so that it will work in form of array. All right, so let's go ahead and just insert these map elements here. So I already have the frequency map. Now what I would do, I will just take this int key frequency map dot key set, right? So this is having all the key, right? I'm just iterating my frequency map, right, so that I can build this bucket list. Now let's go ahead and check this guy. So int frequency, if I need to take the frequency, then what I will do, with the first element frequency map dot get key, this particular key, if I do get key, then it will give me the frequency. Remember, this is my map, right? If I choose another black color maybe, then this is my map, right? And this key will dot get key will give me this corresponding value. Dot get 2 will give me this frequency. Dot get 3 will give me this corresponding frequency, and that's what I'm doing here. So this is frequency, right? And now let's check these buckets. So buckets frequency, right? Frequency is nothing but it's a size of, I mean, this is the size of that particular element, right? So this size is 2, right? So this frequency is this index is getting denoted by the size of frequency. So here size and frequency have the same meaning here. So if this frequency is null, then go ahead and add the new array list that assigned to that particular index, right? Buckets frequency dot add, and I will add this particular key, and then we are done, right? So this key is nothing but this is the particular key. Let's say 1 is the key, and this frequency is 1, right? Frequency is 1 means it will go to this index 1 to the bucket list. I will add 1 here. I will iterate another next key, that is 2. That size is 2. So size means frequency here. Frequency is 2, right? So it will go to the second index. I will add this 2 here, right? Similarly 3 has the frequency 1. It will go to the index 1 and I will append comma 3 here, 1 comma 3, and that's what I'm doing, right? In the next iteration this particular index will not be null, so it's not going to add new array list, and then it will be adding to the same list. So in this case 1 is already there, it will append 3 with the same index, right? If index does not contain any list, then it will be initializing the new array list to that particular index. Now third is basically we just need to fill our output list. So what we are going to do, we are going to iterate this bucket list from the last. So let's say integer position equals to this buckets, and this buckets is num start length -1, right? Because we maintained this basically till this length, right? Nums dot length +1, right? So in fact this will be the nums dot length, right? And position, because this is index based, right? When I say nums dot length +1, then the last index would be, this is the size here, right? And the here I am accessing the index, that's why it's nums dot length, right? So position is greater than equal to 0 and position -. So let's check, because in this case if I go to whiteboard and if I say 6 is null, 5 is null, 4 is null, I don't need to unnecessarily iterate each and every index if it is null, right? So I will just check if it is not null, buckets. So this buckets position, if it is not equals to null, then only res dot add, and I can do add all. Why I'm doing add all? Because this particular bucket index is having the index having the new array list, right? And this is another collection, so that's why I'm doing the add all. So that's why it will add all the elements in that list. So for example, if it is having 1 3, it will add 1 3 at once. If it is having 2 4, it will add all the 2 4. So that's why I'm doing add all here. And this is nothing but buckets on this particular index. So in this particular index, this list I have already added for that particular size or particular frequency, and I think I am done. Let's go ahead and compile, check for the compiler error. Alright, so cannot be converted to int. Okay, list integer cannot be converted to int. Alright, I think I got it. What does that mean? So this buckets, okay, so because what's going to happen, this is basically, this is the container of the list itself, right? So that's what it's happening, and this particular every index is containing another list, right? So that's why it's saying this list integer cannot be converted to int, and that makes sense. So let's go ahead and resolve that issue. And how we can resolve this issue is we can just get the list from the container list, right? So let's go ahead and do this. So this is my list, buckets. Okay, I think I don't need to do this. So alright, this will be basically num start length itself, right? I don't need to, because that was my mistake. I was taking the whole list itself inside this list, so I just need to iterate through the location, right? So this location, and then next previous location, and then previous location. Once I have this position, this index, then I will get that list and I will add that. Sorry about that. So let's see, 1 2 3. Okay, so it's getting another extra, and the reason is that because it's expecting only till k elements. So that's why what we will do, if this if it is only k, right? So what we will do, if res dot size, the same formula here as well, if it is less than k or not. If it is less than k, if it is reached k, then we will stop our iteration. It should be less than k so that it can add the next element till its size is k. So this is the idea. uh, However, we optimized our time complexity is order of n and space complexity is order of n as well, because we have to maintain this bucket list, and then with the bucket list we are just increasing the size order of n times. Let's quickly check whether it's getting submitted or not. So it's getting submitted, and runtime we got little bit benefit as well, right? And in so it's 11 millisecond, earlier it was 12, right? So anyways, this is like just a little bit optimization, and that's the expectation of the problem as well, like if we can do the better of order of n log n, right? So one solution was with the help of heap. This solution is with the help of this bucketing thing, bucket sort, we can say it. So we are just getting one list, and that's containing again the index wise. Index is just a frequency, right? And in that particular frequency we are attaching these element, these keys from the map, that these are the keys and this is the frequency. And from the last, because we need to iterate from the last, from the highest frequency, that's why we are iterating from the last itself. From the last we are just filling our output list till the size of k. So hopefully this was useful. This was pretty lengthy explanation, but if it is useful, then it's worth of the time. Thanks a lot. Have a good one. Bye.